Okay, so we are now going to talk about risk, and it's going to be just mostly talking. Um, I'm not going to try to do much in the way of calculations because they won't really make any sense, and you'll just be like watching me do math. And what we'll do is when we go through the demonstration homeworks, I think some of them have you do some of these calculations. So that'll make it a lot clearer. But we do want to talk about what we mean by this idea of risk. So if you remember from the last video, we left off with this idea of, making a 40% return on baseball cards over the course of a year seems a little excessive, right? Um, and so what we are going to use for a definition of risk is just uncertainty. Okay, it's uncertainty about the outcome. And so, that's the thing about stocks, right? You don't know what's going to happen to the price of a stock. You don't know what's going to happen to the success of a company. If you invest in a startup, you don't know what's going to happen to the market for baseball cards if you make that investment. And so, the degree of uncertainty, the greater the uncertainty, the more risky an investment. And so, that basically is the entirety of what we're saying here in this first section, section 8.2. Right? So, what we're interested in, right, is trying to get our heads around how you actually measure risk. I mean, we have this idea of risk, we don't know what's going to happen, but how can you actually measure the degree of risk associated with different types of investments? Okay. And so to introduce that idea, the next section in the book gives you this very long table of returns on various different types of investments. Right? So we have U.S. Treasury bills, which are essentially no risk. You know that the U.S. government is going to pay their debt, right? And so those are essentially considered a zero risk investment. And then I want to note one thing. Your book, interestingly, uses a different term for one of the things that they're talking about up here in the paragraph than they do actually in the table headings, right? So we've got 4 table headings: 3-month T-bills, long-term government bonds, and then large company stocks and small company stocks. And then up here in the paragraph, they say large cap stocks and small cap stocks. What cap means is capitalization, and you will hear large cap and small cap used, this is part of that like Wall Street lingo, right? You're not going to hear large company stocks and small company stocks. You'll hear large cap, small cap, for portfolios that include those types of stocks. And so, anyways, these tables give the returns historically between 1950 and 2000. And so you see, and they also give a sort of decade by decade average. So in the 50s, large cap stocks had an average of a 20% return, and small cap stocks had an average of a 22% return, and T-bills were 1.87, and long-term government bonds were lower. In the 60s, large cap stock returns went down relative to, they started at 20, average in the 60s was 8.74, small caps were right around 20 again, etc. And so this table just gives you, a lot of data, right? So, but when you go down to the end, we say on average, U.S. Treasury bills provided 5.23% returns for 3 months, annualized. Long-term government bonds were a little bit higher. Large cap stocks gave an average return of 14.89, and small cap stocks gave an average 50 return of 17.10% annually. And so, it looks like small cap stocks are the best investment based on their return. And this table also gives another statistic, which is the standard deviation. So they give you the mean here, right, average, and then they give you the standard deviation. And if you remember from Management 140, standard deviation is a measure of variability, but it is the average spread from any individual observation to the mean, right? And so what this means is that although small cap stocks have a bigger return, 17.10% average return over these 50 years versus 14.89, they have a much bigger standard deviation. And so to the degree that uncertainty about the outcome can be sort of expressed by the variability in the outcomes, aka the standard deviation, we can say that small cap stocks are quite a bit riskier than large cap stocks. Much higher standard deviation. And so the chapter goes on with histograms which show the sort of the shape of the distribution, and you can see that the T-bills, have a nice sort of normal distribution here. The longer term treasury bonds are spread out a little more, and the small cap stocks are, virtually, very, very widely spread out. And so that is basically what this section in the chapter gives you. And then the next chapter the next section in the chapter goes on to discuss standard deviations as a measure of risk, which I've already sort of described. And this literally gives you the formulas for calculating variance and standard deviation. But guess what? We can do that in Excel just as easily, and I am not going to make you calculate a standard deviation by hand. That's craziness. What you should know, though, is that for a normal distribution, right, by definition, a normal distribution gives, first of all, the sigma here is the abbreviation for standard deviation. Mu, that's the Greek letter mu, is the average. So if we have a standard normal distribution with an average of 0 and a standard deviation of 1, that means that 34% of the observations will fall within one standard deviation, plus or minus. And this is like if you had taken a full-blown statistics class, you would have had this kind of drilled into your skull. I don't think that 140 really goes into this, but a standard normal distribution means that 34% of the observations fall within one standard deviation of the mean, which means that 68% of them fall between -1 and +1 standard deviations of the mean, and 95% of all observations fall between 2 standard deviations of the mean, right? And so if you look back at the return for the small cap stocks, we had a mean of 17.10 and a standard deviation of 29.04. Right, so 68% of the observations should fall between -11.94, which is 17 minus 29, and 46.14, which is 17 plus 29. And if we wanted to, we could actually go in and count all of the observations and verify that this was the case. But the thing is, right, what does this actually mean? What does this mean for us when we want to compare different investment choices. Right, so we know that 2/3 of the observations fall within one standard deviation plus or minus the mean. Right? What does that actually mean when we're talking about how we can compare different investment choices? Okay, so here is just sort of a summary. We had a 5.23 average return and a standard deviation of 2.98%. Small caps had a 17.10 and a standard deviation of 29.4%. And so you can actually plot that line, the relationship between returns on the y-axis and risk on the x-axis. And here we have Treasury bills, zero risk, low return on average, see, 5.23. We have government bonds, right? Slightly higher return, higher risk. We have large company stocks, higher return, higher risk, and small company stocks, higher return and higher risk. Okay. So the more risk you are willing to accept, the greater the potential return for the investment, but also the greater potential for loss. So that was 3 sections of this book where we just kind of briefly talked about concepts of risk. And when I go through the example quantitative, practice problems, we'll work more with the numbers, and you'll see how these go. But the whole point of it is we kind of built up the argument that we can measure risk by looking at historical returns, and that once we know the risk of a particular class of investment, we can understand the trade-off between the returns and the risk, right? So that's piece 1 of figuring out how to value stock, right? First thing we have to do is understand what we mean by risk and what that implies for expected returns. Okay? More to come.